Assalamualaikum. I am Hashmi and I am your tutor. Welcome to our intermediate part 1 math series. In this video I am going to explain the topic properties of the real number, which comes under the exercise number 1.1 for the chapter number 1 number system. So it is quite different from the previous topic. In previous topic we have discussed how to prove any specific number which comes in under specific category of the real numbers. So, if you want to learn that topic, you have to go back and watch the video. So, let's get started with today's lesson, which is about the properties of the real number. So, before going to start the properties of the real number, I am going to explain what is binary operation. So, the binary operation is, as the name also symbolizes binary. Binary means 2, okay, and we know that operations in a maths either is positive, is addition, multiplication, division, okay. So we have some basic math operations over here, and binary symbolizes 2 numbers, okay, 2 numbers. So what is binary operation? Specifically, you have to take 2 numbers, any of 2 numbers from any specific set. I am going to represent set as S. Okay. So this symbol shows that A and B belongs to the set S. Okay. A and B are 2 numbers, random numbers. Okay. If I am going to apply any of these operations over here, collectively we can write these operations like this, or any of them. I'm going to apply over here. So if this operation is applied in both numbers, so the answer must belong to this set also. Okay. So it means these two numbers follows the binary operation. Okay, now we have some laws over here. So I am going to explain all laws on specific operation. Okay, not on a specific operation. I am going to represent this as a generalized operation, and you can specifically prove laws by taking addition, either multiplication, either division. It's up to you. Okay, I am going to make a general rule for you. So let's have a look on this. Okay, to make it easy for you guys, I'm going to make a comparison between two operations. Okay, I'm going to apply the laws over here for addition, and you have to make it the laws for the multiplication. Okay, so this one is for your home task. So I'm going to make addition laws. So the properties are same, but the operation is different. Okay. So here the operation is addition, okay, and here the operation is multiplication. So the first property is closure law, okay. As the name symbolizes, closure means closed. So it means if you have taken any of two numbers from the set, as we have discussed. I'm going to discuss about the real numbers, so I'm going to take 2 real numbers. Okay, so if A and B belongs to the real number, so the resultant, when I'm going to apply the addition on both of them, the answer will give me the element which is also belongs to the real number. Okay, so I'm going to generalize it for all real numbers. So this symbol shows all. Okay, the reverse sign for the A alphabet is going to represent the all. Okay, so the all numbers from the real numbers. If I'm going to take random number, and if I take 2 numbers from the real number and going to apply addition over here, so answer must belong to the real number. If answer is in between this set, this means these numbers or these sets have followed the closure law. Okay, So we can say we can have a statement like A and B have the closure property, or the set have closure property under the addition. Okay. Now, second property we have, this one is first property, and the second property we have associative law, right? So associative law, if you are going to explain or the proof associative law, you have to need three numbers. Okay, unlikely to previous, you have to need three numbers. So I'm going to write like this: for all three numbers belongs to real numbers. So you can say like three elements from the real numbers. And if you are going to apply this addition like this, okay, or if we are going to operate A plus B, means operation on first two and then third element, and answer is within the set of real numbers, and answer must be the same. So it means real number follows the associative law under the addition, right? So the third property we have additive inverse. Additive inverse, as the name symbolizes inverse. Inverse, whenever inverse is applied to any of number, it will give you an additive identity. Because we are going to discuss addition, so we have an answer of additive identity. So we can say like that, for all real number, if I am going to take any element from the real number and there is another number, okay, when there exists any number in this set which when applied with this operation, it will produce no change in that number. Okay, as we have A, okay, so we have A belongs to the real number and there exists 0 in real numbers. And if I am going to add 0 in A, there is no change in A, okay, there is no change in that specific number. It means that 0 is an additive identity. Okay, so we can say that 0 is additive identity. Okay, so here we have additive identity instead of. So we have fourth property over here, additive inverse. So for the additive inverse, it means we have a number. We have to take one number from the real numbers, and there exists any other number from the real numbers, any other element from the real numbers. When it is applied with this operation, it will give you an additive identity. When the answer is additive identity, it means this element should be an additive inverse. I'm going to write over here additive inverse. Okay, so we know that 0 belongs to the real number, right? So A and negative of A both are additive inverse to each other under addition. Now we have fifth property, which is commutative law, right? So we have commutative law, as name symbolizes. All the properties are basically, you have to understand what the names have any information. So commutative properties mean commutate. Okay, it means you have to switch, whenever you have to switch the position, answer will be the same. commutative law. Okay. So if we have two elements, A and B belongs to the real number. So if you are going to change the position under this operation, the answer will be same. If the answer will be same, then we can say that these elements which comes under the real numbers have the commutative property under addition. Now it's your turn. Now you have to prove all the properties. Now you have to prove all the properties for the multiplication. So I have proved these properties for the multiplication also. The first property is clear. Again, similar to this, associative property and multiplicative identity instead of additive identity. And similarly, in multiplicative identity, we have a rule like whenever we are going to apply the operation of multiplication, it will give you a no change. Okay, whatever the number over here is, you can say that this one is the identity. Okay, now the fourth property is multiplicative inverse. Okay, so the multiplicative inverse is the element. When you are going to apply with this, you will have an answer of multiplicative identity. And again, the last commutative law, whenever you are going to switch the position, you have the same answer. Okay, hope you understand this topic, and see you in next video, which is this part of this lecture also. So if you have any confusion, you can ask me in the comment below. See you in the next session.